Thermometers are one of the most important tools in the chemistry laboratory. They're easy to use, but since they're usually made of glass, they have to be handled properly. One common misconception is that lab thermometers have to be shaken down like medical thermometers. Shaking is totally unnecessary, and it can be dangerous. The liquid inside can move freely up and down on its own without shaking. Some lab reactions take place at higher temperatures than an alcohol or mercury thermometer can stand. The temperature of oxidation in a Bunsen burner flame is around 600 degrees Celsius. That high a temperature will vaporize the liquid inside. The resulting pressure will break the glass. But most lab experiments are conducted at temperatures from 120 degrees Celsius down to minus 20 degrees. And for that range, either a mercury thermometer or an alcohol thermometer is suitable. No matter which type you use, always treat it carefully. When you're finished with it, set it down where it will be safe. Lay it away from the edge of the bench on a wire screen or towel so it can't roll off. When a thermometer breaks, the glass and any liquid that spills out must be cleaned up and disposed of properly. This is a job for your teacher. Glass fragments can be swept up. If any alcohol happens to escape from the glass, it can be wiped up with a paper towel. Cleaning up a broken mercury thermometer is more difficult and also a job for your teacher. Mercury is poisonous, and it won't soak into a paper towel. Mercury vapors also can escape into the air. If you work with mercury thermometers, your lab may be equipped with a mercury cleanup kit or sponge. The kit and broken glass should be disposed of in the proper container. Don't shake thermometers. Use thermometers only in the temperature range they're suited for. Lay thermometers down on a towel or wire screen to cool, away from the edge of the bench. Let your teacher clean up broken thermometers. The most common lab injuries are cuts from broken glass, especially glass tubing. A typical accident comes from using too much force to push a tube through the hole in the stopper. One way to avoid this kind of accident is to use an inserter. First, dip the Teflon tip in a glass lubricant such as glycerin. Then push it through the stopper. Remove the tip and slide the tubing through the hollow inserter shaft. Removing the shaft leaves the tubing behind. Make sure to wash the lubricant off the tubing and stopper before using them. And replace the Teflon tip so it doesn't get lost. To remove the tubing, take out the tip and lubricate the end of the hollow shaft. Push it through the stopper hole around the tubing. Then slide the tubing out through the shaft and remove the inserter. Remember to wash the lubricant off before returning the stopper and tubing to storage. And don't forget to replace the tip. If you don't have an inserter, lubricate the tubing instead. And protect your hands with leather gloves. Push the tubing gently through. Rotate it if there's any resistance. Use the same care when removing it. And don't forget to wash off the lubricant. Use an inserter to place glass tubing in a stopper or remove it. Or lubricate the tubing and protect your hands with leather gloves. A centrifuge spins mixtures around in test tubes to separate solids from liquids. The solids move out toward the bottom of the tubes, and the liquid stays on top. When the test tubes inside aren't evenly distributed, the centrifuge is unbalanced. It vibrates like a washing machine with an unbalanced load. If the vibration is bad enough, it can fall off the benchtop. To prevent vibration, a centrifuge must be balanced. If you're only centrifuging one test tube, place another one opposite it with an equal amount of water. Once the centrifuge is balanced, you can turn it on. When it's finished, turn it off. Then wait till it stops spinning on its own. Never try to stop a centrifuge with your hand. Place equally filled test tubes in a centrifuge to balance it. Don't try to stop the spinning with your hand. A safe lab session starts with proper clothes. You must wear clothing and equipment that will protect you from chemicals and flames, and at the same time, stay out of your way. For example, sleeves that are too loose can drag through a chemical puddle or knock things over. The wrong material is also dangerous, as this mannequin demonstrates. Fuzzy sweaters or filmy fabrics can easily catch on fire. Synthetics such as polyester melt when they burn and stick to the skin. The right kind of clothing includes sleeves and shirts that fit fairly close, but aren't too tight to restrict movement, and fabrics made of sturdy cotton or wool that won't melt and stick to your skin. A lab apron keeps most splashes off your clothes, but you should still wear older clothes underneath in case any chemicals get past the apron. Legs are vulnerable to chemical splashes and broken glass if you drop something, so long pants or a long skirt should be worn to protect them. Open shoes can't protect your feet from spills. Closed leather shoes are much better. And shoes made of cloth or woven material can absorb spills and hold harmful chemicals against your skin. Besides wearing the right clothes, there are other precautions you should take to avoid accidents. Tie up loose, long hair. It could knock something over or even catch fire. Remove rings and watches. They can trap corrosive chemicals against your skin, and the chemicals can damage your jewelry. Your eyes are the easiest to hurt and the most important to protect. Don't wear contact lenses in lab. They may trap chemical vapors against your eyes. If that happens, your eyelids may go into spasms that make it impossible to remove the lenses and wash out the chemical. Always wear goggles with side shields to completely protect your eyes, even if you're already wearing glasses. And finally, protect your hands. Never use bare hands with concentrated acids, bases, or other reactive chemicals, such as concentrated hydrogen peroxide. Your teacher will tell you what type of gloves to wear to work with these chemicals. With the right clothes and protective equipment, you can work with laboratory chemicals with confidence and safety. Don't wear extremely loose clothing. Fabrics should be sturdy and natural. Wear older clothes and cover them with a lab apron. Wear long pants or a long skirt to cover your legs. Wear closed leather shoes to protect your feet. Tie up long hair. Remove rings and watches. Take out contact lenses. Cover your eyes with goggles with side shields. Protect your hands with the right kind of gloves. A chemistry laboratory is full of beakers and bottles holding chemicals. Fooling around can have disastrous consequences. You could scar yourself or others for life, even cause blindness. So the most important rule of all in the lab is no fooling around. Don't run, push, or wrestle, or even move fast. Even if you're not fooling around, accidents can happen.
Wait a second.
Personal belongings in the middle of aisles can trip someone. Even a job as simple as reading a burette can lead to an accident. For greatest accuracy, your eyes should be on the same level as the number you're reading. If you can't read a burette accurately, lower it down to eye level. If you can't do that, stand on a step stool. There are behavioral rules to protect you against less obvious hazards, too. Applying makeup may seem harmless enough, but chemicals and vapors and spills in the lab can contaminate it. Then when you apply it to your face, you put on the chemical, too. So keep makeup outside the lab. Eating and drinking in the lab can cause similar problems. Chemicals can contaminate your food or splash into a drink.
Guys, I think it's time to go to class.
Can't be.
Get rid of them before you come into the chemistry lab. Don't fool around in lab. Keep aisles clear of personal belongings. Stand on a step stool when you have to reach. Keep makeup in your purse. Keep food and drinks outside. In spite of safety precautions, people sometimes get careless and accidents happen. That's why a well-equipped chemistry lab has emergency equipment to take care of them. If you've cut yourself, wash the wound to remove any chemical traces. Make sure there are no pieces of glass in the cut. Dry your skin carefully so a bandage will stick. Let your teacher put the bandage on the cut. Notify your teacher whenever you have an accident. And make sure to get immediate medical attention after any injury in the lab. Chemical spills and splashes are also common lab accidents.
Ah! Are you okay? My eyes. Let's go wash them out.
If a chemical hits your eyes, wash them immediately in an eye wash fountain. Hold your eyes open and roll them around so the water can wash them thoroughly. You shouldn't be wearing contacts, but if you are, get them out as soon as you've given your eyes a good initial rinsing. Continue washing for at least 15 minutes. Then see a doctor immediately to check your eyes for damage. Non-corrosive chemical splashes on bare skin should be rinsed off in the lab sink with plenty of water. Spills of corrosive materials require a lot more water. Don't wait till you feel pain from the chemical. Head for the safety shower immediately. Rinse your body thoroughly as fast as possible. Take off all your clothes. Don't let modesty make your injury worse. Your teacher will clear the other students out of the room. Stay under the shower for at least 15 minutes. Fires are always a potential hazard in chemistry lab, especially when organic liquids are involved. Small fires in containers can often be put out by covering them. Turn off the burner so the fire won't reignite. Larger fires require a fire extinguisher. It should be operated by a teacher, not by a student.
Hey, fire!
No, let's leave.
If the fire is too large to control, clear out of the building. Call the fire department when you're safely outside and tell them what chemicals are involved. Clothing fires can be put out in a couple of ways, as the mannequin will demonstrate. The best way is in the safety shower. If the shower's not close by, the rule is stop, drop, and roll. The victim's weight on the fire puts some of it out, and a fire blanket gets the rest. Flames should be kept away from the victim's face. Anyone who's been burned must get medical attention immediately. Clean and dry the skin around a cut before a bandage is applied. Rinse chemicals from your eyes in the eye wash fountain. Rinse chemicals from your hands and arms with water in the sink. Remove your clothes on the way to the safety shower to rinse large spills from your body. Extinguish small fires in containers by covering them. Let your teacher use an extinguisher to put out larger fires. Put out clothing fires in the safety shower. If there's no other way to put out a clothing fire, use a fire blanket carefully to keep flames away from the face and neck. The accidents in this program may look serious, and many of them are. But don't let the potential for danger scare you away from chemistry lab. A safe, well-run chemistry lab is an interesting and rewarding learning experience. If you pay attention, use common sense, and follow the safety rules you've seen here, the chemistry laboratory can be safer than your own home.
There is another version of lab safety rules in the list format. You can also access this one for getting all the information regarding the safety in the chemistry laboratory. So as I told, I've already shared the PowerPoint, these documents and video demonstration with you. So I hope these three will help you to get a clear idea about the lab safety rules. And another thing I would like to share with you, the MSDS. This is material safety data sheet for MSDS. And as I earlier told you, will get the information of the substances or chemicals that you are going to use from this MSDS. Material safety data sheet, or other name is safety data sheet, or SDS. This is one of the examples of MSDS describing sulfuric acid, like a different section, and according to different section, the information has been listed in this MSDS. Section 1, which type of chemical, what is the name, its CAS number, and different other information, synonym, and composition, which type of substances are present there, hazardous identification, hazardous information, potential acute health effect, potential chronic health effect. First aid and measure, that means whenever we are being affected by the sulfuric acid, what should we do? If it is connected with the eye, skin contact, serious skin contact, inhalation, serious inhalation, ingestion, then serious ingestion, fire and explosion data regarding the fire and explosion data of sulfuric acid. Is it flammable or non-flammable? And flashpoint, flammable limit, product combustion, fire hazard. So all these are related to the fire explosion data of the sulfuric acid. Accidental release measure, whenever it is released or spilled or sprayed, what should we do? What should we do in the case of small spill? What should we do in the case of large spill? Handling storage, how to handle and how to store the sulfuric acid. Exposure control, so personal protection equipment. Does it require any personal protection equipment? And what could be the exposure limit? Physical and chemical properties. In our theoretical part, we will also learn about the physical and chemical properties. And here, now physical and chemical properties of sulfuric acid have been described in the MSDS. Other information, molecular weight, vapor density, vapor pressure, volatility. Stability and reactivity data, most of the cases related to the chemical properties. Toxicological information, how it could be entered inside our body, or how it could enter through the skin. Toxicity to the animals, chronic effect to human, other toxic effects on human, special remark on toxicity to animal, special remark on chronic effects on human. Ecological information means how it is making any adverse or harmful effect on the environment when we are disposing them. Disposal consideration, how to dispose. Transport information, when we need to transfer the sulfuric acid from one place to another place, what should we do? Other regulatory information. So for any of the chemicals that are unknown to you, and if you are intent to use those chemicals, it's good idea, good practice to find out the MSDS, that means material safety data sheet or safety data sheet of the particular substance or chemicals, and study them and use them whenever necessary.